The process of manufacturing a microprocessor. Engineers and designers create a detailed blueprint of the microprocessor's architecture. The manufacturing process starts with a circular and thin silicon wafer. High-purity silicon is melted and slowly cooled to form a single crystal ingot. It is then sliced into thin wafers. Multiple rounds of cleaning and polishing are done to remove impurities and defects from the wafer's surface. A thin layer of silicon dioxide is grown on the wafer's surface to create an insulating layer. Testing. At various stages of the manufacturing process, the wafers are tested to ensure that the components are functioning correctly and that there are no defects. Packaging. Maku. Once the wafer contains all the necessary components, it is cut into individual chips. Each chip is then packaged in a protective housing, which includes pins or contacts for connecting the chip to a circuit board. Final testing. The individual chips undergo extensive testing to ensure they meet the required performance and quality standards. Assembly. The packaged chips are assembled onto circuit boards, along with other components like memory, power supplies, and connectors, to create the final product, such as a computer or smartphone. The entire process is carried out in cleanroom environments to minimize dust and other contaminants. The production of microprocessors is a highly precise and capital-intensive undertaking that involves advanced technology and expertise. Even small defects or errors in the manufacturing process can render a chip non-functional or reduce its performance. Photolithography. This step involves using a mask and ultraviolet, UV light, to transfer the processor's design onto the silicon wafer. The mask contains a pattern that defines the location of transistors, interconnections, and other features. When the UV light is shone through the mask onto the wafer, it creates a pattern on the wafer's photoresist coating. Etching. Chemical etching is used to remove the exposed areas of the photoresist and silicon dioxide layer, leaving behind the pattern of the processor's features. Ion implantation. Ion beams are used to selectively introduce impurities into the silicon wafer, altering its electrical properties in specific regions. This is done to create the necessary transistor characteristics. Deposition. Thin films of various materials, such as metals and insulators, are deposited onto the wafer's surface using techniques like chemical vapor deposition, CVD, and physical vapor deposition, PVD. These films are essential for creating interconnects and other components. Chemical mechanical polishing, CMP, but excess material is removed, and the wafer's surface is polished to create a smooth and level surface. Repeat steps. These steps are repeated multiple times to create multiple layers of transistors, interconnects, and insulators, building up the processor's architecture.